Hey guys, Jay Bish here for your first installment of quarantine content. Welcome to the new class for the foreseeable future. Hope you guys are able to stop, pause and rewind and all those other fun things you can do with online content. Unlike normal class, feel free to grab some snacks and relax, having some knowledge thrown at you in this more easygoing format, giving you a bit of a rundown of how these lessons are going to be put together, what the expectations are, and how you guys are going to have a chance to participate more in some of these classes as well. I want this to be as interactive as possible while still maintaining some of those social protocols that we have in place. We are going to be doing some live demos and graphics should be coming up around me, as well as some linked tutorials and finally, some basic note taking that you guys are used to while I use my iPad and help you guys to actually contribute and help to convey some of the information a bit more easily than what would normally be happening in class. So let's jump right into it. Just a disclaimer, all the notes from today's lesson, all of those notes from today's lesson are going to be up on Canvas in the normal sense. So you guys feel free to go and download those notes as the videos come out and there'll be more information built into those notes. There isn't too much left in this lesson though, so feel free to just relax and enjoy some of this information that's going to get thrown at you. For this lesson, the learning goals are going to be the same, if not, they're going to be similar to what they were before. And each of the learning goals are going to be put up here into this section into this section of the video. But since we started this lesson already, feel free to just listen to my voice as I walk you through what we're actually going to be doing. So what have we covered already? We've looked at the homologous series, trends in these series, as well as some functional groups and effects that these have, like alcohols, aldehydes, ketones, and carboxylic acids. The last four things that we're going to be talking about today are esters, amines, amides, and halogens. First up, esters. Let's kick this off. These are those sweet little functional groups that give that fruit a really sweet and really rich scent, okay? Recall, esters are those functional groups with a double bonded oxygen and a single bonded oxygen over here. It looks like this molecule just here. Those are those functional groups and they're connected to another chain, another carbon chain on the end of that. But what are those functional groups, what effect do those functional groups actually have on the actual molecule itself? So what effect do they have on the boiling point and the melting point and all those other things I'm about to tell you? Here we see a nice table. If you look over the side here, you will see a nice table. And under it will pop up the structures as I talk about them. Methyl methanoate with a boiling point of 32 degrees Celsius. Methyl ethanoate at 57 degrees Celsius. Methyl propanoate at 80 degrees Celsius. And ethyl methanoate at 54 degrees Celsius and ethyl ethanoate at 77 degrees Celsius. The addition of those extra bonds makes it require more energy, okay? More energy, which means more temperature, more heat has to be put into that reaction in order to break those bonds. Group number 2 for today are amines. Amines are those groups of molecules that are based around a nitrogen. So you can see here, there's an amine right here. That molecule is based around a nitrogen. We have primary, which has one non-hydrogen bond, secondary, which has two non-hydrogen bonds, and tertiary, which has 3 non-hydrogen bonds. In short, the properties of these guys are very similar to the aldehydes and those ketones. Basically, the more hydrogen bonds that you get put in, that are in these molecules, the harder it is to pull them apart. That means that tertiary, those ones with 3 non-hydrogen bonds, are generally much easier to dissolve and have much lower melting points and boiling points when compared to those primary amines. On to our third group for today, amides. Much similar to these ones, amides, just up from this carbon bond, there's a pesky little double bonded oxygen linked over here. It looks a little bit similar to those esters where you've got that double bonded oxygen, but that single bonded oxygen has been replaced with that amine type group. This double bonded oxygen means that it's able to transfer or translate these electrons around the entire molecule, meaning that these, of any other molecule, have some of the highest boiling and melting points of any organic molecule. It's over 200 degrees Celsius for some of those molecules. Conveniently, these are going to be quite easy for you to dissolve though in water solutions. Finally, we're going to talk about this last group, halogens. Halogens are those groups in group 17. So all those compounds, all those elements that are going down in the periodic table in group 17. As you go down the periodic table, those elements, those halogen elements, get larger and larger and larger due to more electrons being in the outer shell. The larger these molecules get, the more resistant to change they become. So the further down you go, the higher the boiling point and the higher the melting point is for those molecules, those halogen. And that's it for chapter 9, guys. We'll follow up these lessons with some of those online discussion forums. You guys are going to have the opportunity to contribute and ask questions, engage ideas. At the end of this lesson, there are some of the check your learning questions and those review questions. Feel free to jump on. All of those answers are actually on Canvas already to go, so feel free to download the questions. Let me know how this goes for you guys. Let me know what you would like to see. Let me know what you would like to happen in these videos. Until next time, thanks for listening, guys. Keep safe, keep healthy. Peace.